Hello and thanks for the nice introduction. My name is Henning and I will show you the usage of SolidSteel parametric for SolidWorks with the example of a staircase design. It will look pretty much like this one in the end and will take about 15 minutes. Let's start. Here we see our starting point. We have a wall of a house with a door on the right and a window on the left. And we want to build an escape staircase or entrance staircase, it doesn't really matter how we call it, in front of the entrance door. We are going to hide the wall for a while. Now we see our sketch, which has a height of 1400 mm, and we simply start by placing a stair from line 1 to line 2. Because SolidSteel parametric remembers all the settings, we can see that the stair is already the way we want it. I've done this before. However, if we look at the settings again, it is shifted to the right. We have two extensions, one horizontal, one vertical. We have an extra step. And we have a floor offset of 20 mm at the top. That's just because we know there's another 20 mm of floor on top of the beams. You can see now that the steps of the stair adjust accordingly when you set this value. We create the staircase. It takes a moment, of course. SolidSteel creates 6 profiles, miters them, places the profiles in the welded assemblies with the stringers, creates the steps, places all the holes, and of course places the bolts. This simply takes some time. Okay, here's our finished staircase. We can see that 2 welded assemblies have been created along with the steps and the bolts. Here at the back we want to create a connection to the wall, so let's place 2 profiles. The first one we are going to move down. The second one we are just going to place centered on the sketch line, but rotate it. You don't have to do that, but it just looks nicer. And now of course we want to add a little more detail. First we make a miter cut at the corner. And then a face cut for the angled profile. Of course you can't cut this at right angles. Now let's take a look at this corner. I've already prepared a custom joint that includes the double clip angle connection, a cut and also the small rib for the back. And well, there we see that the complete joint has been created, including all the bolts, etc., with just one click. Next we unhide the wall, because we need the surface to cut the bottom profile with a face cut. We could of course place an end plate here now, but I'm going to leave the cut as it is, so the webinar doesn't get too long. Okay, then I'm going to hide the wall again, just to make it easier to work on the stairs. Of course we also want to place a railing. We are going to do that by attaching it to the side of the stringers. We just select the face and the edge, and we get this partial preview. We tweak the alignments a little bit so that everything lines up the way we want it to. And then we place the railing. The railing is template based. We load the template, automatically create an independent copy of it, and that independent copy is then placed in the assembly and adjusted to the new geometry. That's why it takes a little while. Now we are going to edit the equations because these templates are controlled by them. For example, we want to have 2 segments with 9 rods each. So we click OK. And now we see that the railing is changed according to the new equations. But of course, these changes are not made to the template, but to the independent copy. Okay, we are going to do the same thing on this side. There's a small gap between the stairs and the wall, so we are going to place a railing here as well. The values entered are now reversed because the orientation is mirrored. Otherwise, same procedure, same waiting time, same story. So again quickly, we adjust the equations, in this case identical to the railing on the opposite side of course. And as I said again, we open the assembly once, update the equations accordingly, and then SolidSteel does the parametric changes because these are SolidSteel parts now. But of course the railing could be made of any other parts as well. These two railings were pretty straightforward. Now it gets a little more complicated. We are going to add these side railings, the smaller ones up here, and for this we are going to use a trick. First we'll set the parameters so that the posts are exactly aligned here. And here on the right side we are going to extend beyond the end of the construction. The reason for this is because we want and need to do this corner connection. We see that the railing templates are always straight, so we have to do a little trickery. We cannot do a 90 degrees corner out of the box, so we have to place two railings and then connect them. The first short railing is placed. We change the equations. In this case, let's say we have two segments with only 4 rods. Well, the machine is working for us again. And there is the modified railing. Now we see on the left side that it doesn't fit, but we'll ignore that for now. We'll take care of that in a moment. Let's add the last missing railing. Proceed in the same way as with the previous ones. Now place the overhang here as well, so that we have an exact alignment here in the corner. In the direction of the house wall we pull the end a little inward so that, for example, an end plate would fit neatly onto the profile later. Of course you can make your own templates for this type of railing with, for example, the required overhang on the right and left already in place. Users who design railings on a daily basis will create their own templates anyway. That's the nice thing about having to create templates only once and then being able to use them flexibly over and over again. However, the way I'm doing it right now, you'll also get there pretty quickly, as you'll see in a moment. Now that the railing is in place, we are going to adjust the equations again, so that the railings fit to each other. This is where the assembly reopens, the equations are updated and the parametric update is performed. We already know that. Now we can see that the railing is more or less finished. It looks like a piece of modern art, of course we can't leave it like that. This means that we are now going to suppress all the parts we do not need. As I said, we could have used a different template, but it's also a very quick way, of course, by saying, come on, just kick out all unnecessary parts. This small one up here also has to be suppressed. Now let's look at the corner. Here we simply make a miter cut between the two handrails. Select it, click OK, and we're done. Then of course we have to adjust the length of the short joints. In this case I could have selected both bars. I don't know why I didn't, so let's do it again. So now this detail is completely done. Let's take care of the next one. We are going to kick out all the corner elements. We don't need them anymore. By the way, the suppression is important so that they don't show up in the parts list later. We could just hide them, but as I said, we also want to have a clean parts list and then the parts have to be removed, that's obvious. So now we have the two bars at the top. We suppress those as well and then we just have to join the corners. We do that with miter cuts. Of course we could have mitered the boxes, those segments with the bars, but I'm going to do it this way. It's a matter of personal preference. Here I accidentally selected the wrong element. Of course these two are right. Another click on OK and the point is done. That looks pretty good. Let's unhide the wall again and quickly trim the back handrail with a face cut at the front of the wall. Last but not least, we shorten the handrail that extends into the doorway. To do this, we select this face select the profile and confirm. Oops! I was too quickly with the confirmation. The cutting direction was indicated by a very visible green arrow pointing in the wrong direction. Well, of course, I only did this to show you the Remove Cut tool. So we are going to remove the cut by selecting this profile, because we selected the face there. Now everything is back the way it was before, and we do the whole thing again. This time we just activate Flip Cut Direction, see the green arrow pointing in the right direction, confirm, and the cut is done. This completes the entire design of our staircase and railing. Well, as we all know, after construction is before production. I switch to the Position Numbers tab and click Update. The identical part detection is working and is now checking the entire design. If we switch here, we see a list of position numbers or a list of parts. Now we are ready to export the BOM. We simply select one of the templates, choose a path to save it to, and confirm to start the export. This is very quick. Let's have a look at the result. Of course, there are lots of entries for staircase. All the handrails, all the stairs, of course many sections, welded assemblies and also railing assemblies. Here in the sheet list we have only one sheet, the rib. And here in the quantity list, of course, everything as an overview. We could create the XF drawings now, but with only one sheet it is almost not worth it. Instead we export a shop drawing of a beam using the drawings function. Simply select the beam, choose a drawing template and confirm. This automatically creates a dimensioned drawing. As you can see, SolidSteel covers the entire process chain in steel design, and it would go even further with our DSTV Assistant, which I will now also show briefly. The DSTV Assistant is a standalone add-in, so it can be used by steel distributors, for example, who do not design themselves but still have to deal with their customers' components on a daily business. Now I just click on Quick Start, and as we can see, all the solid bodies of the assembly are now analyzed. Finished. Here in the overview you can see that all the profiles have been recognized, and combined with the machining operations, we could now automatically generate DSTV NC data for production. This works not only with SolidSteel parts, but with any 3D solids that SolidWorks can import. But this is just a small preview of the features, as the topic of DSTV NC data is beyond the scope of the webinar. That brings us to the end of this part. Thanks for your attention. Now it's time for your questions, and I'll hand back to our hosts. Bye bye!